So in these trend explanations, these questions, and I think each of them is either a free response or a multiple choice that I've modified from actual AP questions. I'm not totally sure why, but over the years, explaining periodic trends has become one of my more favorite things to do in both first year and AP chemistry, because it is that application of facts that we know, but really helping it to explain kind of the right way what atoms are doing. So I'm going to move my head out of the way a little bit here, oops, for this first one, and then we will look at all of these together. So there we go. So using the principles of atomic structure, and that's normally your header when you're asked to think about Zeph and shielding, explain why this is larger. Sometimes you'll see this in multiple choice with lots of options. It ends up being a multiple choice question with lots of reading because each choice is long and each choice is going to be super convincing. They're going to use chemistry facts that you've likely heard before, but they're going to use them wrong, or they're not going to use the ones that explain and prove it. So it's really important to remember that it is Zeph and shielding that proves what we know. When we're doing these explanations, we do want to talk about both of those. Both elements are in group 1 and have the same Zeph, because sodium has 11 protons, lithium only has 3, so sodium almost has 4 times as much positive charge. But we need to acknowledge that most of that is canceled out, and by stating the Zeph, we have done that. Sodium uses 3 energy levels, lithium only uses 2, so the outer electrons in sodium, much more shielding, much more distance, and therefore ends up as a larger radius. So you don't want to just ramble and ramble on this, but you want to state what is the same out of Zeph and shielding, what is different out of Zeph and shielding, and then how does that specifically connect to our property. So you're kind of looking for maybe 2 to 3 sentences, and using phrases like Zeph and shielding are ideal. And you can even write these as sentence fragments. You can write them as bullet points. You are not graded on the quality of your writing. It is how you use the right top numbers. So down here, we've got our second one. Sorry, I am clicking incorrectly, but we are looking at chlorine and argon. I know that in its original format, this was a multiple choice question, and almost everybody picked the wrong answer, which was saying argon is full. Yes, argon is full, but why does being full make this different? So both are in period 3, same shielding. First sentence, maybe what's the same? The additional protons, the more positive charge, the more Zeph changes that for those. More positive charge attracts the electrons, therefore it's harder to remove. So from a claim evidence reasoning format, I ended with my claim, argon is higher. My evidence was, what do I know about shielding? What do I know about Zeph? My reasoning is, what does that mean in relation to my claim? I actually did this in one of the previous videos, forgetting that it was a question, but just wanted to think that we can turn ionization energy and electron affinity into reactions. And we have to think about energy in versus out, and what are we doing with our electrons. So atomic fluorine gains an electron, absorbs energy. Totally messed up what I was saying, kind of going to my default there that it's likely to gain. But in this case, we're talking about ionization. So I've made the it's not fluoride, fluorine plus 1 ion by releasing an electron. This is an instance where we are looking at successive ionization energies, first versus all the way up to 5th, and using that to know about an element. So it says we're in period 3, which means our options are anything from sodium up to argon. The right answer, the claim, is aluminum. Low values for ionization energies 1, 2, and 3 mean that those electrons are valence electrons. They are easy to remove, but going from the 3rd to the 4th, we are about 5 times bigger. So here we do triple, there we don't even double, but when we have a jump of 5 to 6 times or more, that is the big jump. Those electrons are much closer to the nucleus, much stronger. So the 3 valence electrons connects to aluminum. This one was a recent AP test as well. So it gets into our transition metals, but it's still just asking us to think about, well, what are the things that I know? So using the principles of atomic structures, we're talking about Zeph, we're talking about shielding, we're talking about protons, we're talking about electrons. Why is this bigger than that? So it's important to state what's true or the same about both of them. Both have 26 protons. The difference is 24 versus 23 electrons. That is going to change. Less repulsions, allowing them to be closer. And there, I'm going to change my is to are, more protons or more Zeph per electron, which is going to pull that in a little bit closer. So very often you're even given the trend. You don't need to know what it is, what's bigger or smaller. You just need to be able to think about, what do I know about atomic structure that proves that?